Good morning. I hope you guys are doing well. We're going to go ahead and dive right into our next lesson, 1.11, No Solutions and Identities. Today's date is September 7th, 2016. Please make sure that you have this written at the top of your notebook and you're ready for notes. Now, as you guys talked about in your Do Now today, sometimes when you're solving equations, things look really crazy. Your variables might eliminate, your numbers might eliminate, you might be left with nothing. And you have to determine what this means. So it's really important to get a couple of definitions out of the way first, and we're going to start with that of an identity. Make sure you have this complete definition copied in your notebook. If you need to pause the video, please do so, but I'll try to wait to give you plenty of time to get this written down. An identity. You know that you have an identity if the variables disappear. And you get a statement that is always true. So after your variables disappear, much like they did in your Do Now, you should get some kind of statement that's always true. So like 1 equals 1 or 4 equals 4. If you get something like -3 equals 8, obviously those two numbers are not true, so that would not apply here. So you're looking for that statement that's always true. And then there are infinite solutions. So what that means is that these two lines, when you graph them, are identical. They're exactly the same line. So if you look at this picture here, I have a picture of a line that is blue, and it just so happens that the red line is the exact same line. That's why you can see both the colors kind of showing in there. So sorry, I dropped my pen. So you can see both the colors showing there. That shows you that these two lines are the same, and then if I pick any point on this line, either one of these lines, it's going to be on the other line as well. So all of these points are solutions. They're all the same. So as we were saying at the beginning, if your variables disappear and you end up with something that looks like this, then you know that you have an identity, which means you have infinite solutions. That means it goes on and on and on and on. Make sure you have this complete definition copied down, along with the example and just a quick sketch of the graph. It doesn't have to be beautiful, just make sure that you have this graph there as well so you keep it in mind, that you just have the same line. We're going to go ahead to the next important definition here, and it is if you have an equation or two equations that give you no solution. So if your variables disappear, like before, and you get a statement that's never true, so that means like these two numbers are never, ever, ever going to be equal, then there's no solution. This means when you graph it, the two equations would form parallel lines. Parallel lines are lines that never, ever intersect. Think about like the lines on a road, the two yellow lines, they are on either side of the car for a reason. If they intersected, then there would be nowhere for your car to go. You have to have that running space in between. These two lines are never going to cross, so they're never going to give you a solution. There's never going to be a point where they intersect each other. It's going to look just like this graph. So when those variables disappear, if you get a statement that looks something like this, and it's absolutely not true that 0 is equal to 5 or 4 is equal to 7, then that means you have no solution. Make sure you have this complete definition copied, along with the examples and the graph sketch. All right, let's go ahead to example 1. Make sure you have this copied down in your notes. Example 1, 4 parentheses 2x plus 3 equals 8x minus 12. Now, it's important to remember here, this means that you're multiplying the 4 by everything inside the parentheses. So I'm going to go ahead and draw my arrows here so I remember that I'm using distribution. So if I do 4 times 2x, that's going to leave me with 8x. And then the 4 times the 3 is going to leave me with 12. And then I'm just going to write down everything that was on the right side of the equation. So 8x minus 12. Now some of you can probably already look at this and tell what's going to happen, but we're going to make sure we walk through all the steps together and we have a really clear picture of what's happening. So the first thing I want to do is to get my like terms on the same side. So I'm going to start by trying to move over this 8x to the other side using inverse operations. So if I subtract 8x from this side, then I have to subtract 8x from this side. When I subtract those 8x's from a positive 8x, they cancel on both sides. So this is one of those cases where your variables are gone. I'm simply left with 12 is equal to negative 12. Now, you should be able to look at this and tell that this, in no way, shape, or form, is a true statement. If I have $12, I have way more than I do if I'm in debt $12, or if I have negative $12. They're not true. So since this is false, it means I have no solution. So in other words, these two lines, these two equations or expressions that I have here, if I was to graph them, are never, ever, ever going to intersect. Let's look at example 2. Make sure you have this copied down. I have 3 times parentheses negative 5x plus 4 plus 9x equals negative 2 times parentheses 3x minus 6. Go ahead and get your first step finished here. Remember what operations are really important, what properties you might see. Take just a minute and get this started silent solo on your own. Go. So you should have realized that your first step was distribution. So I'm going to take my 3 and distribute it through the first set of parentheses here on the left. And I'm going to take the negative 2 and distribute it through on the right set of parentheses. When I start with the 3, I get 3 times negative 5. That gives me negative 15x. And then 3 times 4 is going to give me a positive 12. And then I'm just going to write my 9x and my plus sign the way that I see it. Equals, and then negative 2 times 6, or 3x, so sorry, is negative 6x. And negative 2 times negative 6. And negative times negative is always a positive, so 2 times 6 is just going to give me a positive 12. Now, if you look back at your notes from 1.06, you should remember that you have to combine terms on the same side that are alike before you can start doing any inverse operations. Look carefully. Do you see any terms that are the same? You should have noticed that this negative 15x and this positive 9x are the same. If I have different operations like I do in 15 and 9, then I know I'm going to subtract. So 15 minus 9 is a 6. I'm going to keep the operation of my biggest number, which is the 15, so it's negative 6x. So now I'm done with both of the variables, and I'm left with plus 12 on this side. And then I'm just going to bring everything else down. So negative 6x plus 12 equals negative 6x plus 12. Now, at this point, you can probably see that these two equations or expressions on each side of the equal sign are exactly alike. I have negative 6x, 12, and 12. But to prove that this is true, I'm going to go ahead and finish. So plus 6x on both sides. I bring down my wall, this eliminates, and I'm left with 12 is equal to 12. You guys should know this is always, always true. So this means I have infinite solutions. These two equations here are what we call an identity because we have infinite solutions. All right, we're going to work out that one last example. Example 3. We have 32 plus 8n equals 8 parentheses 4 minus n. 32 plus 8n equals 8 parentheses 4 minus n. I'm going to start with distribution the same as I had before with this 8. So before I do that, I'm going to write down everything that's on the left side of this equation because I'm not going to really mess with it yet. So 32 plus 8n equals. And then I'm going to do this 8 times 4, which gives me 32. 8 times negative n, which gives me negative 8n. Now, I'm sure some of you right now are thinking, oh, I think I know what this is, but let's check and make sure that our gut is telling us the right thing. So to start this, remember we're going to build that wall. I like to start with the variables first. So I'm going to go ahead and move over this 8n by subtracting. So my positive 8n and my negative 8n on this side are going to cancel. I'm going to bring down my 32. So 32 equals 32. But if I look carefully here, I have negative 8n minus 8n. This doesn't cancel. I'm simply just going to combine my two negative 8's, which is going to give me negative 16n. So this means I'm going to solve this like a normal equation. I'm just trying to get n by itself. My variables haven't canceled. I'm going to keep going. So I'm going to go ahead and move my 32 to both sides by subtracting. So my negative 32 and my positive 32 cancel here. And then I have a positive 32 and a negative 32 that cancel here. Now, they cancel because 32 minus 32 is going to give me a 0. So I'm going to write that down as a placeholder on the side. I don't want to forget that I have something that this negative 16n is combined to. Now, the biggest thing that's going to happen is you guys are going to hit this step and you're going to say, oh, Miss Greenway, there's no possible answer. This is wrong. You haven't finished the problem yet. What do you need to do to get n by itself? That's right, you should divide both sides by negative 16. When you type in your calculator 0 divided by negative 16, you should get that n is equal to 0. That means this is a solution. We just only have one solution here. This is a wonky one solution. So sometimes it doesn't cancel at all, and you just find that answer like we have been all along. Do not get thrown off. If the numbers eliminate and give you a 0, as long as you still have a variable, you're going to solve it. Go ahead and make sure that you try the rest of the problems in your packet. You have 4 problems to try out. Make sure you show every step and explain whether or not it's no solution, if it's an identity with infinite solutions, or if it just has an answer. After you finish that, go ahead and move on to your exit ticket. Remember, you're turning all of this in at the end of class into the drawers by the door when you leave. Have a great day.